number one, which one correctly identifies an open and closed skill? So you need to know that an open skill is to do with the environment and how it can be affected by the context that we play it in. A closed skill is something much more fixed and the environment doesn't really affect it. So let's have a look at those examples. Well, the answer's A. So first of all, why is receiving a serve in badminton the most open skill out of this list? A, you've got an opponent deciding where the serve goes, so it can go anywhere. Yes, within a square, but it's their choice where it goes. In contrast, you've got things like the hole. The hole is in a fixed position, it's not moving when we're putting a golf ball. The distance could vary, but in that example, it's in a fixed position. Passing a ball while on the run, well, that could be quite an open skill. But if we look at the example for a closed skill, surfing along a wave, that's very changeable. So this seems quite open to me. So straight away we rule that one out. You can see what we're doing here. We're using the process of elimination to find the best answer. Cycling on an exercise machine, very, very closed because nothing is changing. Yes, you can cycle faster, you can cycle harder, but it is a fixed environment. There's no weather, there's no terrain differences. You're riding by yourself. So the answer is A. Taking a penalty kick in soccer, it's not a completely closed skill because the goalkeeper will be there, they might be putting you off, they might influence where you go, but the penalty spot is fixed and the goal is fixed. So it's a relatively close skill. Number two, what is an ability? So we need to know that an ability versus a technique and a skill is a different thing. An ability is what we inherit, so it might be to do with our fast twitch muscle fibres making us quite fast, versus having a naturally large heart or high number of red blood cells in our body. That would make us obviously higher VO2 max, higher stamina. So an ability is something we inherit. If we look at the other things, learning to shoot, learning to throw a ball, and learning how to score in football, these are all skills that take time to be acquired. Remember we said that often in these MCQs there's often an odd one out, one that's got a difference to the rest, and in this case the odd one out is actually the answer. It's the ability. Jump height in a vertical jump. Yes, you need to learn how to jump, but it's something we call a fundamental movement skill, an FMS. We learn that when we're very young. So jumping is to do with what you inherit, your fast twitch fibres. Number three, the chart shows the learning curve of a golfer. So we can see that we've got some acceleration, we've got some slowing down of learning, and then we've let me say that again. We've got some learning going on. We've got a big acceleration in learning, and then we've actually got a plateau in learning. So this is where we're starting to slow down and not see much progress. You could see that if you have a look at the way performance is quantified by the percentage of success in this golf example. And obviously it's over time. So learning occurs over time. We've got different rates of learning. This is the most significant period of learning, and it's actually asking you about that here. So between 5 and 7, we've got a sharp increase in performance. Remember, performance is here, so the answer is D. This is a plateau. Well, it's negative in a way, but it becomes a plateau at the top. And this is also positive, it's just slower than this. Number 4. The diagram shows a javelin thrower. What type of skill transfer occurs when an athlete uses their knowledge, and the key is there, the key is very much there, their knowledge about angle of release. So I know that when I angle my body upwards or I tilt my head upwards, I'm going to go in that direction. I know that if I angle the javelin this way rather than that way, I'm going to get more vertical height. I'm going to get a trajectory like this rather than like that. So knowing that is the key here, and this is why the answer is A, principles to skill. The principle of trajectories and objects in motion, the principle of large and small angles of release. If we look at the others, skill to skill would be something like throwing a tennis ball to throwing the javelin. Abilities to skill would be something like, maybe having a really long arm, long levers, which gives you more, potentially a bigger distance if you've got long levers. Or power, maybe lots of fast twitch fibres in the muscles so that you can release it quickly. D, practice to performance. Well, Yeah, javelin is practice to performance, really, because the way you practice it is exactly the same in performance. There's not really a difference. So if it was this guy doing a standing throw and then in competition he's doing a run up, that would be practice to performance. There's a difference. But in this example, how you practice the javelin is exactly how you perform it, so that one doesn't work. Let's have a look at 5. A coach plans training sessions with periods of work and short breaks in between. Now, a lot of you this felt like a messy one, so let's have a look at this. Periods of work and short rest breaks in between. Which type of practice is this? Well, we know for a fact it's not massed, because you don't get rest in massed practice. I think some of you might have said B and C. I think these are common answers as well. But drill is, maybe it could be a drill, but the answer's D for a specific reason. It's to do with this idea of rest breaks. So when we've got rest, it's almost like an interval, and that's why the answer here is distributed practice. Variable is when it's mixed, so we mix up the way we do the drills, and drill is when it's fixed. It's exactly the same each time. 50 free throws would be a fixed practice or a drill practice. So the answer here is D. Question 6, which is an example of reaction time? Okay, so we need to know the definition of this one. So reaction time, you remember that we also learned about response time and movement time. And we use the example of a 100-meter runner responding to the gun. So reaction time is the time from the sounding of the pistol, so the stimulus, to starting the movement. So if you think about how does a runner get disqualified in a 100-meter run or a swimming race, it's because they react too quickly, and they might get DQ'd for that. So starting your movement early would be illegal reactions. So that's reaction time. Which is an example of an exteroceptor. An exteroceptor. So this is, I think most of you did quite well on this, things on the outside of the body, not internal senses, but external senses. So the answer here is to do with the sense of touch on the hand. I think, again, just like we said before, process of elimination, all these things, all these other things are inside the body. They're detecting changes inside, even including the inner ear. This is to do with balance. And your balance apparatus is deep inside the ear. That's why if you get an ear infection or any sort of problem with your eardrum, you might actually lose balance and struggle with that, and it needs resetting with a doctor. Number 8, a coach trains their team to use a number and letter sequence. So this is something you did with me, did a little PowerPoint research, Google Slides research task on it. So what do we mean by a number and letter sequence for a penalty move? Well, the answer is coding. So if I show you very briefly, I'm going to show you these ones so you can maybe pause. Oh, I think we have. Let's see. Here we go. Right, if you want to pause the video and have a look at the 4 things that are on screen here, so rehearsal, chunking, etc., coding is organising information and attaching a code or label to the group. So it's literally coding it. If you were looking through your notes and you had your notes as 6.3, 6.2, 6.1, which we do, that's a system of coding. So check the others if you need to, and perhaps print those notes off if you didn't before the test. Question number 9. The graphs represent something to do with Hicks' law. So a change in reaction to do with the number of options that we get. So what we said on this one, and we did this with the card task, I gave you lots of different tasks with those coloured cards and you had to respond. And what we found is that the more options that we get, the slower our responses get. So if we think about this being positive, because things are getting faster. Let's see. Yeah, things are getting faster. In this sense, things are getting slower. And we know that it actually does start to plateau here because we've got a really low reaction time here. We've got a really high reaction time up here. Yes, it goes through a period of rapid slowing here, but it continually slows all the way through. So as we get more options, things slow down, and that's the answer. The other graphs kind of have the opposite effect. We have, one option, turn the cards over. Why would that be really slow? So this is your biggest number. That means it's a slow time. So we're looking for option C down here. Last two questions. Number 10. This is something that we learn in terms of we've got the three memories. We've got STSS, the short-term sensory store, which is thousands of pieces of information. That gets filtered into the short-term memory, and then we can compare that information to what we've already previously learned, which is in the long-term memory. What we said is that most people have what we call a limited channel capacity. Limited channel capacity. And they can only hold and process and deal with so much information at one time. So the answer is 7 pieces of information, but some people might be better or worse than others. I think there's an error here and there should be a minus according to the syllabus, but some people might be a bit better and they might be able to hold 9 because 7 plus 2 is 9. Some people might have a terrible working short-term memory and maybe can only hold 5. We're talking about obviously healthy people, not someone who's got a concussion, for example, and can't remember their name. So, 7 plus 2, plus minus 2. And then the last one, the diagram shows Welford's model. What does X represent? So you need to know that this is all to do with lots of information. This is all the stimuli. This is our perception, which is DCR. This stuff here is to do with our memory. So we start to filter that stuff down into the short-term memory, compare it to the long-term memory. So what is X? Well, X is, we've done the comparison, we've found a match with the memory. X is actually going to be, decision making. So where does effective control come in? Well, this is you doing the action. So controlling you doing your football kick or tennis serve would be here. This would be C. D would be your long-term memory. We're comparing things back to the long-term memory and making sure we've got a correct match. And the other one, your short-term sensory store, well, we get all that information kind of coming here. We've got loads and loads of stimuli here. It then gets perceived and filtered and recognised and sent into the short-term memory. So we've kind of got the short-term sensory store. A would be kind of here. And that's it.